So starting out is triangle congruency with SSS and SAS. If all corresponding angles and sides of two triangles are congruent, then the triangles are congruent. However, you can prove triangles congruent using fewer parts. The using fewer parts part, that's us doing side congruency, side angle congruency, angle side angle, or HL. That's us using fewer parts. Like if you know a full triangle, like all the sides and all the angles are congruent to another one, yeah, you can prove the triangle congruent. But it's saying we can do that with less parts by using one of the 5 congruency rules we learned yesterday. The first one is side. If you know both sides on both triangles are congruent, then you can prove two triangles to be congruent. In this case, we're just writing the statements out over here. It says if and AB is congruent to segment DE, and then segment BC is congruent to segment EF, and then segment CA is congruent to segment FD. If we know that, then we know that triangle ABC is congruent to triangle DEF. This is about side congruency. Alright, so looking at a proof based off side. Directions: fill in the missing statements or reasons. So in your proofs that you'll do, you'll have either missing reasons or missing statements. It'll never be as many as we're showing you right here. We just started out that way so we can show you how to write the full proof. When you're doing it on the test, you may only have to answer one missing reason or 2 missing reasons or a missing statement or something like that. It usually isn't that hard on the test. Or they may make you drag and drop stuff in order, however they design it on the test. But if you understand the concept of these proofs, you should be okay. These are triangle congruency proofs. Traditionally, they're set up like this with a statement and reason table here. You have statements that they give, and you need to list the reasons for those statements that they make based off what was already given to you. So in a proof too, they'll always start you out with some given information. They'll either literally give it out to the side here like they did here, or they'll give it on the figure by marking stuff congruent on a figure, or marking stuff perpendicular, or marking stuff parallel. They'll either state it on the figure or they'll state it out to the side. They'll always start you with some given information in your proof. And then in this case, they want us to prove that these two triangles are congruent. Triangle JKL, triangle NKM. Other sheets you'll need to have out while we're doing this. The notes from yesterday, I told you it wasn't even really notes, it's a reference sheet. We're going to use that reference sheet today, because if you look over here at the bottom of the first page, it says reasons sides are congruent, reasons angles are congruent. This is our little reason bank right here. Is based on what we read, we're going to end up choosing some of these reasons. And these are some other ones too, not typically used, but sometimes we do use these. You need to have this sheet out if you don't have it out already. Alright, so flowing through, starting out, given, it says JL is congruent to NM. It tells me those two sides are congruent to each other. First thing I want to do, since they tell me that, is mark that on my figure. JL is congruent to NM. These are sides, so I'm doing side markings. Then after that, the next piece of given information, it says KM is the midpoint of JN, that side, and the midpoint of side LM. I want to indicate that on my proof. So they told me K is a midpoint, and then they say it's a midpoint of side JN. Let's talk about that first. If K is the midpoint of JN, what should I know about that segment JN? Go ahead. You gotta be more specific. Tell me what's equal.
JK is equal to KN.
Yes. Since they call K a midpoint right here, you should know that the length of JK whatever it is equal to the length of NK. Here, I can mark those congruent. They say K is the midpoint of LM too, so the same thing applies for LM. Since K is a midpoint, I should know that of LM, I should know that LK is congruent to MK. Alright. So that's all my given information, and based off that given information, I was able to mark that stuff. But if you look just on this one, it won't always happen like this. Just based on the information that was given, I can kind of pretty much tell how I can prove these triangles congruent, can't you? I'm asking, can you? Yeah. And y'all know which example this was anyway, SSS. So we've already marked up SSS on this one. But we just need to fill out our proof and make sure we're good. On this one, starting out, the first statement says JL is congruent to NM. That's a statement. How do I know JL is congruent to NM? Yeah, literally it was given. And that's what you're going to write, given. If the information is given and they put it in the proof, just write given next to it. The next line, they say K is the midpoint of JN and LM. Dior, how do I know that? It's given. Given information. Alright, next line is where we're going to have to start making decisions. That's all my given information if you look at the top. That's it. Next line says JK is congruent to NK. Kind of cut off the bottom of the congruent symbol, but that's what it's showing you. JK is congruent to NK. I need a good reason for that. Now this is when you want to look at your reasons reference sheet. On the reasons reference sheet, it says reason. I'm in a reference sheet. It says reason sides are congruent. Those are sides. So Vince is starting me out. Huh? No. Jamal? No. And mine, you gonna do the whole thing, I guess. Definition of a midpoint. Look at the sheet, man. Reason sides are congruent. We only give you 3, really. Reasons we will prove sides congruent. Definition of a midpoint. And it says out to the side, a midpoint will create 2 congruent sides, right? That's what they just named for you. JK and NK, they're 2 congruent sides. We know that because K is the midpoint, so this is definition of a midpoint. Next line. So line 3 was definition of midpoint. The reason, next line. LK is congruent to MK. How do we know those two are congruent? LK is congruent to MK. Same exact thing. Definition of midpoint. Thank you, sir. Alright, we done made it to the end. We're at the point where we want to prove a triangle is congruent to a triangle. Triangle JKL is congruent to triangle NKM. You got your hand up, Jamal? Yes. No, sir. No. SSS. We're proving. Side, side, side. Alright. Oh boy, here we go. Let me pause this. We back at it. On the back, side angle side. If two sides and an included angle of one triangle are congruent to two sides and an included angle of another triangle, then the two triangles are congruent. She told you to go back. You're messing up my video. I'm just telling you what she told me, bro. I ruined about 20 seconds of my video. So, a side angle, side. All we're doing over here is writing the statements. If AB is congruent to E or DE, excuse me, and angle B is congruent to angle E, and then segment or side BC is congruent to side EF. And then we know triangle ABC is congruent to triangle DEF. This is side angle side congruency. Included means the angle in between the sides. I'm sure y'all know that now. Alright, so let's do a proof with SAS in it. Given JM is congruent to LN. Also given angle JMN is congruent to angle LNM. They want us to prove that triangle JMN is congruent to triangle LNM. So we need to mark our given information first. Given, they said JM is congruent to LN. Then after that, this is when, in proofs, this is usually when my kids run into trouble. Because as much as I've taught y'all this, y'all still struggle with it. I've shown y'all how to name angles. I show y'all how to mark angles when they're called out to you. But y'all still struggling with this. Y'all marking the wrong. If you mark the wrong angles, you're going to read it wrong. The middle letter is where the angle actually is. I don't know how many times I need to state this to y'all. The middle letter is where the angle actually is. The other two letters just guide you. So JN, angle JMN, this angle right here. The reason they named it with three letters because they say angle M, they could be talking about that full angle there. They're talking about the angle on this side, JMN, here. They say that's congruent to LNM. LNM, mark that angle for yourself. They say those two angles are congruent. That's given information. Alright, riding through our proof now. We marked all our given stuff. JM is congruent to LN. Reason being, what, Kevin? Given. Then on the other line, our statement is missing, but they say given. What should go there, one? This ain't no trick, but I think your focus off, man, because you should be able to answer that pretty quickly. Nasir, go ahead. Thank you. Juan, all I'm asking you to do is state what's already written at the top, man. This next line. New piece, but you're gonna see this a lot. Guarantee you're gonna get access at some point. This says MN is congruent to MN. These are sides. It says side MN. I read that wrong. MN is congruent to NM, and that's written correctly. Let's say MN is congruent to NM. So go back to your reasons. What's the reason that sides are congruent? What's one that could fit here? Miss Johnson. Yes, reflexive property. Explain this to you. Call it reflexive property of congruency. Out to the side, it kind of explains it. It says a side that is congruent to itself, and we know these sides are congruent because they share a side. So that's reflexive property. That's what it looks like when they share a side like that. That's going to be reflexive property. Y'all know when they share that angle in the middle, that should be vertical angle. So if you ever get those, they ever name those angles for you, you should mark those as vertical. But in this case, it's sharing sides. It's reflexive property. Only thing I will say is it does matter how it's written in the statements over here. They wrote this one MN is congruent to NM. They did it that way for a reason. Let me show you. I'm gonna go to another page. You can stay where you at though. We'll show you another one that has reflexive property, but it's written differently, and I can explain to you why. On this proof right here, we'll get to this in a little bit. It says YZ is congruent to YZ. On this one, they wrote both of them the same way. Look at the figure though. On this figure up here, this looks like a reflection to me. It looks like it just flipped over on itself. Yes. Since it's a reflection, when I name my triangles, they're going to be named the same way. So I can name this first triangle WYZ and this triangle XYZ. The YZ is going to be in the same spot on both triangles. This is a reflection, so it should be YZ is congruent to YZ. It still reflects a property, but you write it as YZ is congruent to YZ on this one. Alright, because anytime you got the flip, they should both be named the same way. I want you to go back to the one that we're looking at now. On this one, this doesn't look like an exact flip, does it? This looks more like a what? What kind of transformation? A rotation. Specifically 180 degrees. If it's the 180 rotation, then it needs to be written like this. MN is congruent to NM. Reason being, because when you name the triangles, like say I was to name these triangles, they already did for us actually. Look at the way they named them. They said triangle JMN, JMN. So going from here, JMN is congruent to LNM. LNM. If you see what matches up, side MN matches up with NM. Y'all follow me? It's based on the way it's named because it's a rotation. So that's why you have to write it like that down here. And we will mark you wrong if you don't write it right. So you just got to understand, the ones that look like flips, you write it the same exact way. The rotation ones like this is where it's going to be written backwards. MN is congruent to NM because of the rotation. Alright, I just want to make that clear because my kids mess up on that. Alright, then we need to mark that as well. So MN is congruent to NM. Put 2 marks there since we already marked the pair of sides. And then from there you should be able to read the congruency. It should be obvious because that's the name of this one. Go ahead, Jamal. SAS. Alright, so that's 2 down. Got 3 more. Next one, angle side angle. If 2 angles in an included side of one triangle are congruent to 2 angles in the included side of another triangle, then the triangles are congruent. That sounds like that might be old boy. We'll see if he knock on the door. So got the image out here. We're just writing our statements. If angle A is congruent to angle D, and segment AB or side AB is congruent to side DE. Let me say it the right way. And angle B is congruent to angle E. Then the triangles are congruent. Triangle ABC will be congruent to triangle DEF. This is by angle side angle congruency. Alright, so included once again means the side in between the angles. Let's get it. Fill in any missing statements or reasons. On this one, starts out, it says given SQ bisects angle RQT and angle RST. SQ bisects angle RQT and angle RST. RQT is this big angle that's on both triangles here. If I bisect angle RQT, what am I doing to it? You're splitting it in half. So that means the 2 smaller angles that are created by that split will be congruent. You need to mark those. You need to mark them correctly. RQT is this full angle right here. Q is the middle where the angle actually is. I'm splitting it. I'm bisecting that with this segment here, SQ. If that's the case, they calling it a bisector. If that's the case, the small angle up top will be congruent to the small angle at the bottom. And I stagger it a little bit too, so you can see that I'm marking two angles congruent to each other. I stagger my markings like that on purpose. Then on the other side, it said SQ also bisects angle RST, the big angle over here. It gets bisected as well. So if it bisects that, I can mark the two small angles congruent that way. I can mark this small angle right here congruent to this small angle on the other side. I'm doing two markings this time though, and I'm staggering still just to show you that I'm marking two separate angles. When you start marking it up, it becomes obvious which way they're trying to prove congruency with you. But it's key to mark it up. You have to mark your figure. And like I was explaining to the kids in the other class, when I grade y'all proofs, the first thing I'm going to look for is if they're marked. If they ain't even marked, if they blank, I'm just going to mark your whole problem. I don't even care if you got everything wrong. Everything right in your statements and reasons. If this is not marked up, your figure is not marked up, I'm marking your stuff wrong. Because I know you don't really know what you're doing. Are you trying to do it without it, and you're going to end up making a mistake. So these need to be marked based on what's given. What's the other thing? Oh yeah, and even when you get to a test, the test is going to be on the computer. You're going to have scratch paper. I want you to draw the figure out on your own paper and label it and mark it. You need to be able to do that. Be lazy about it, you're going to get them wrong. Alright, so after all that, then it says prove triangle QRS is congruent to triangle QTS. So I'm trying to prove the triangle's congruent. First thing it tells me in the statements is SQ bisects angle RQT and angle RST. 1. What's my reason for that? Given. Too good to be true.